Get ready. 3 seconds to go. Start. We use different kinds of fuel for various purposes at home, in industry and for running automobiles. Full stop. Can you name a few fuels used in our homes? Question mark. Name a few fuels used in trade and industry. Full stop. What fuels are used for running automobiles? Question mark. Your list will contain fuels like cow dung, wood, coal, charcoal, petrol, diesel, compressed natural gas CNG, etc. Full stop. You are familiar with the burning of a candle. Full stop. What is the difference between the burning of a candle and the burning of a fuel like coal? Question mark. Maybe you were able to guess right. A candle burns with a flame whereas coal does not. Full stop. Similarly, you will find many other materials burning without a flame. Full stop. Let us study the chemical process of burning and the types of flame produced during this process. Full stop. Parachange. What is combustion? Question mark. Recall the activity of burning of magnesium ribbon performed in class 7th. Full stop. We learned that magnesium burns to form magnesium oxide and produces heat and light. We can perform a similar activity with a piece of charcoal. Full stop. Hold the piece with a pair of tongs and bring it near the flame of a candle or a Bunsen burner. Full stop. What do you observe? Question mark. We find that charcoal burns in air. Full stop. We know that coal, 2, burns in air, producing carbon dioxide, heat and light. Full stop. We are told that food is a fuel for our body. Full stop. Parachange. A chemical process in which a substance reacts with oxygen to give off heat is called combustion. Full stop. The substance that undergoes combustion is said to be combustible. Full stop. It is also called a fuel. Full stop. The fuel may be solid, liquid or gas. Full stop. Sometimes, light is also given off during combustion, either as a flame or as a glow. Full stop. In the reactions mentioned above, magnesium and charcoal are combustible substance. Full stop. We find that for combustion, air is necessary. Full stop. The candle burns freely in case A, when air can enter the chimney from below. Full stop. In case B, when air does not enter the chimney from below, the flame flickers and produces smoke. Full stop. In case C, the flame finally goes off because the air is not available. These experiences tell you that different substances catch fire at different temperature. Question mark. The lowest temperature at which a substance catches fire is called its ignition temperature. Full stop. Can you tell now why a matchstick does not catch fire on its own at room temperature? Question mark. Why does the matchstick start burning on rubbing it? Full stop. Parachange. The history of the matchstick is very old. Full stop. More than 5,000 years ago, small pieces of pine wood dipped in sulfur were used as matches in ancient Egypt. Full stop. The modern safety match was developed only about 200 years ago. Full stop. The mixture of antimony trisulfide, potassium chlorate and white phosphorus with some glue and starch was applied on the head of the match made of suitable wood, full stop. When struck against a rough surface, comma, white phosphorus got ignited due to the heat of friction, full stop. This started the combustion of the match, full stop. However, white phosphorus proved to be dangerous both for the workers involved in the manufacturing of matches and for the users, full stop. These days, the head of the matchstick contain only antimony trisulfide and potassium chlorate, full stop. The rubbing surface had powered glass and a little red phosphorus, which is much less dangerous, full stop. When the match is struck against the rubbing surface, some red phosphorus gets converted into white phosphorus, full stop. This immediately reacts with potassium chlorate in the matchstick had to produce enough heat to ignite antimony trisulfide to start the combustion, full stop. Parachange, we find that a combustible substance cannot catch fire or burn as long as its temperature is lower than its ignition temperature, full stop. Have you ever seen cooking oil catching fire when a frying pan is kept for long on a burning stove? Question mark. Kerosene, oil, and wood do not catch fire on their own at room temperature, full stop. But, if kerosene oil is heated a little, it will catch fire, full stop. But if wood is heated a little, it would still not catch fire, full stop. Does it mean that ignition temperature of kerosene oil is lower than that of wood? Question mark. Does it mean that we need to take special care in storing kerosene oil? Question mark. The following activity shows that it is essential for a substance to reach ignition temperature to burn, full stop. If we continue heating the cup, we can even boil water in the paper cup, full stop. Can we think of an explanation for this phenomenon? Question mark. The heat supplied to the paper cup is transferred to water by conduction, full stop. So, in the presence of water, the ignition temperature of paper is not reached, full stop. Hence, it does not burn, full stop. The substances which have very low ignition temperature and can easily catch fire with a flame are called inflammable substances, full stop. Examples of inflammable substances are petrol, alcohol, liquefied petroleum gas, LPG, etc. Full stop. Can you list some more inflammable substances? Question mark. You must have seen or heard of fire breaking out in homes, shops and factories, full stop. If you have seen such an accident, write a short description in your notebook, full stop. Also, share the experience with your classmates, full stop. It is important that all of us know the telephone number of the fire service, full stop. Find out the telephone number of the fire service in your area, full stop. If a fire breaks out in your house or in your neighborhood, the first thing to do is to call the fire service, full stop. Does your city oblique town have a fire brigade station? Question mark. When a fire brigade arrives, what does it do? Question mark. It pours water on the fire. Water cools the combustible material so that its temperature is brought below its ignition temperature, full stop. This prevents the fire from spreading, full stop. Water vapor also surround the combustible material, comma, helping in cut off the supply of air, full stop. So, comma, the fire is extinguished, full stop. You have learned that there are three essential requirements for producing fire, full stop. Can we list these requirements? Question mark. These are fuel, comma, air to supply oxygen, and heat to raise the temperature of the fuel beyond the ignition temperature, full stop. Fire can be controlled by removing one or more of these requirements, full stop. The job of a fire extinguisher is to cut off the supply of air, comma, or to bring down the temperature of the fuel, comma, or both, full stop.